Darcy-Weisbach equations is the equations for pipe flow. Here we consider a pipe of section 1, 1 and 2, 2 and P1 with the pressure at section 1, P2 with the pressure at section 2, the velocity and area. And the here pipe is horizontal, so height z1 and z2 are equals, and according to Bernoulli equations, p1 over rho g plus p1 is square upon 2g plus z1 is equals to p2 over 2g plus v2 square into pg plus z2 plus hf. That means head loss. Z1 equals z2 since pipe is horizontal, and b1 is equals to v2 since the velocities of the water flowing are equals. After cancelling out z1 and z2, v1 and v2, the remaining portion is p1 minus p2 is equals to hf rho g. Marking it as equation 1. Said I forgot to write p2. That's my error, minor error. Recalling the process, step 1 we define the terms, step 2 we used Bernoulli's equations and find out the term p1 minus p2 equals to hf rho g. And main thing we have to remember is z1 equals z2 because the pipe is horizontal, and v1 equals to v2 since the water flowing through the pipes are uniform. Step 3 we find out the frictional resistance. Dash equals to frictional resistance per unit weighted perimeter, weighted area per unit velocity. Frictional resistance F dash equals to F dash into weighted area into velocity square. F dash into weighted area means pi dl into velocity square. F dash into pi d means perimeter p, L into velocity square. Step 4 we find out the net forces acting on the section 1, 1 and 2, 2. Between sections 1, 1 and 2, 2. First, at section 1, 1, pressure equals to force upon area, then P1 is equals to F1 upon A. Therefore, force F1 is equals to P1 into A. Similarly, at section 2, 2, P equals to F1, F upon A, P2 is equals to F2 upon A. Therefore, F2 is equals to P2A. Pressure P1 or F1 is positive, whereas F2 is negative. Since considering the directions, this is positive, this is negative. Since the considering the direction of flowing waters, frictional force resolving all the force in the pipe will get resolving all the forces in horizontal directions. P1A minus P2A minus F is equals to 0. And now look at the figure. P1 is moving in this directions, P2 are moving in opposite directions. Therefore, P1 is positive and P2F is negative. P1 minus P2A minus is equals to F. Therefore, P1 minus P2 is equals to F by A. Now, we can substitute the value of F dash into P into L into V square upon A. And assuming P by A, from equations first, we know P1 minus P2 is equals to gamma F rho g. P1 minus P2 is equals to rho g HF. Therefore, rho g HF is equals to F dash P by A LV square. Therefore, HF is equals to F dash P LV square upon rho g. Upon rho g. A also. Now, P by A is equals to weighted area of open area. Weighted perimeter means by D. Area means pi d square upon 4. Substituting the values pi d upon pi d square upon 4 and cancelling out pi d, will get 4 by d. Then putting the value of P by A is equals to 4 by d, we will get f dash 4 lv square upon rho g d. Again substituting the values. F dash lv square 4 by d rho g. Again substituting or putting the values f dash upon rho is equals to f by 2, will get hf is equals to f by 2 lv square into 4 by d is equals, therefore hf is equals to 4 f lv square upon 2 gt, f lv square upon 2 gt, or we can cancel out 2 to the 4, or we can directly write hf is equals to 4 f lv square upon 2 gt. It's so simple, easy. These tips are quite so much easier. The main point to remember are so much easier, so we can write and get the full marks on these questions from the fluid mechanics.